Okay, this is A2Further notes, and we're on chapter 6, differential equations, and we're towards the end of that, just going through a few examples then at the end. So we're asked then to solve this second order differential equation here, d2x by dt squared plus x equals 10e to the 2t, given that when t equals 0, x equals 5, and dx by dt equals 14. So first thing we need to find is we're going to set this equal to 0, d2x by dt squared plus x equals 0. Our AQE in this case, hopefully you can see we've no x term really, or m term, so it's going to be m squared plus 1 equals 0. That's only going to give us then complex roots, and it's going to be then kind of plus or minus I. That means there's no real part to this complex number, so that we first bit then, if we look back a few pages, let's look back actually, sorry for the delay here. If we can find this sheet, then I should be able to bring it up for you. So it's two complex roots here. This here would have been then the real part of it, but that's going to be 0, so that anything to the power 0 is 1, so we just end up then with this wee bit here. So that's what we have. So therefore our complementary function is going to be x equals a cos 1t plus b sine 1t, because this is a 1i here. Hope that makes sense. By observing then the right hand side, we're going to let x equals p e to the 2t and see if we can find then from there. That means dx by dt, whenever we differentiate this, obviously the 2 comes to the front, so we get 2 pe to the 2t, and then d2x by dt squared is going to give us then 4 pe to the 2t. So we're going to then substitute into our original differential equation, and we have it up here. Obviously, sorry, it's this one up here. So we're going to have 4 pe to the 2t plus pe to the 2t equals 10 e to the 2t. That gives me 5 pe to the 2t equals 10 e to the 2t, and gives me a value then of p equals 2. Now on to the next wee bit then. That means our general solution becomes x equals a cos t plus b sine t plus 2e to the 2t. We know, because it tells us that when t equals 0, x equals 5, that's going to give us 5 equals cos of 0 is 1, so it's a, I guess, times the 1, plus b sine of 0 obviously gives us 0, and then plus, we're putting t equals 0, and that's then going to give us 2. So that gives us a value then of a equals 3. We're told then that dx by dt, so we need to find our dx by dt, because we're told in the question whenever t is 0, dx by dt is 14. So dx by dt, if we differentiate this, we get minus a sine t plus b cos t plus 4e to the 2t, and hopefully this will help us work out then our value of b. So we have 14, because it tells us that in the question, equals minus 3, because we have that from earlier, and that's times 0, so it makes no odds anyway, plus b cos of 0 is 1, plus 4, and that means our value of b then equals 10. That's a terrible looking b, and we have that. Therefore our particular solution then at the very end after all of this, therefore we have x equals 3 cos t plus 10. See if you can see where we're getting this from. We're getting it up here. Sine t plus 2e to the 2t.